to channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry for class 11, and that is your class 12 that we have to discuss here. We had discussed your 11th class in the last session, where I told you about that we had done unit 8, that is of part 2 for class 11th is your redox reaction, and we are dealing with unit 9, which is your hydrogen. In terms of hydrogen here, this is an hydrogen that we have to discuss, and the last topic we had discussed about the hydrides, ionic or saline hydrides, covalent and molecular hydrides. And even though we had done 2 of the questions in the last class, if you had not visited you can just go ahead, you will find out the video there. In the same way, coming towards this, we have to start discussing. So on the same way we go for it, and that will discuss about the metallic or non-stiochmetric or interstitial hydrides here. Metallic or non-stiochmetric or interstitial hydrides. So for the same, it will be here for the metallic and the non-stiochmetric or interstitial hydrides, where these are the formed by many D block and F block elements. However, the metal of group 7, 8 and 9 do not form hydride. Even from group 6, only chromium forms a CRH. These hydrides conduct heat and electricity, though not as efficiently as their parent metal do. Unlike saline hydrides, they are almost always non-stiochmetric, being deficient in hydrogen. For example, LaH2.87 and where YbH2.55, TiH1.5 to 1.8. On the same way, ZrH1.3 to 1.75 and VH0.56 and NiH 0.6 to 0.7, we have PDH 0.6 to 0.8, etc. In such hydrides, the laws of constant composition does not hold good. Earlier, it was thought that in these hydrides, hydrogen occupies interstatistics in the metal lattice, that producing the distortions without any change in its type, and consequently they were termed as interstitial hydrides. And however, the recent studies that have shown that except for hydrides of Ni, Pd and CnAc, other hydrides of this class have lattice different from that of parent metal. The property of absorptions of of hydrogen on transitions metal is widely used in catalytic reduction, hydrogenation reactions, and for the preparations of the large numbers of compound. Some of the metals that can accommodate a very large volume of hydrogen and therefore that can be used as a storage media. This property has a high potential for hydrogen storage and as a source of energy as well. So we discuss about another question, which is the third question of the session, and that being the important one. Can phosphorus with outer electronic configuration 3s2 3p6 form pH5? That's what we have a question here, so we'll go for the same. Can phosphorus with outer electronic configuration 3s2 3p3 form pH 5. So we go for the same, and here in the same way, that is, although the phosphorus exhibit +3 and +5 oxidation state, it cannot form pH 5. Besides some other considerations, high delta A of H, that value of dihydrogen, and delta H, that value of hydrogen, do not favor to exhibit the highest oxidation state of P, and consequently the formation of pH 5. So we go for it. So although phosphorus exhibits +3 and +5 oxidation states, it cannot form pH 5 besides some other considerations. High delta AH value of dihydrogen and delta H of H value of hydrogen do not favor to exhibit here, do not favor to exhibit here, and the highest oxidation state of P, and consequently the formation of pH 5. Now we discuss the another important point, and that is here about water. In terms of water here, a major part of all the living organism is made up of water. Human body has about 65%, and some plants have as much as 95% of water. It is a crucial compound for the survival of all life forms, and it is a solvent of great importance. The distributions of water over the earth's surface is not uniform. So the estimated world water supply we will be discussing here, and that you will be get to know about to estimated the world water supply. So estimated world water supply. We have sources and percentage of total. So the first source we have oceans. The second is saline lakes and inland seas. So for the same, for the oceans it is 97.33. For the saline lakes and inland seas are 0.008. For polar ice and glaciers, the next is that is 2.04. Another is your groundwater, which is 0.61. Then we have your lakes, that is your 0.009. Another we have your soil moisture, which is 0.005. Another is atmospheric water vapor, which is 0.001. And the last we have is your rivers, and that is we have your 0.0001 that we have. Now we discuss the another one, which is the physical properties of water. So in terms of physical properties of water here, that is, it is a colorless and a tasteless liquid. Its physical properties are to be given here along with the physical properties of the heavy water. The unusual property of water in the condensed phase, which is liquid and solid state, that are due to the presence of extensive hydrogen bonding between the water molecules, and this led to the high freezing point, high boiling point, and high heat of vaporization and high heat of fusion in comparison to H2S and H2SE. In comparison to other liquid, water has the higher specific heat, thermal conductivity, surface tension, and dipole moment and dielectric constant, etc. These properties allows water to play a key role in the biosphere. So in the same way, we will be going to the physical properties of H2A and D2O, so that we'll be finding it out. So the physical property of H2O and D2O. So we find that here the property we have, this is we have for H2O and this is for D2O. So here we go. Although the first property we have here is molecular mass, mole inverse. Another is melting point, here for the another one, which is boiling point. Kelvin. Enthalpy of formation, which is by kg mole inverse. Enthalpy of vaporization which is 3 Kelvin by kj mole inverse. Another is enthalpy of fusion, kilojoule mole inverse. And the temperature of maximum density by Kelvin. Density viscosity and centipoise. Dielectric constant, which is c square by Newton meter square. Electric conductivity, electrical conductivity 293 Kelvin by ohm inverse centimeter inverse that we have. So we'll go for it. For the first one which we have here is being as follows, and for that molecular mass gram mole inverse, that for H2 it will be 18.0151, and for D2 it is 20.0276. Melting point for H2O is 273 and it is 276.8. Boiling point 373 and 374.4. The another we have enthalpy of formation minus 285.9 and minus 294.6. Enthalpy of vaporization is 40.66. This is 41.61. Enthalpy of fusion is 6 and this is D2, it is not. Temperature of maximum density is 276.98 and this is 284.2. Another we have for density which is 0 and that is 1.059. Then for viscosity and centipoise it is 0.8903. This is 1.107. For viscosity and a constant we have, that is we had on, and the dielectric constant that will we have for 78.39, 78.06. And for electrical conductivity at 293 Kelvin ohm inverse centimeter inverse, 5.7 into 10 to the power minus 8 that we have here. So in the same way, with reference towards this, that is the high heat here of the vaporization and the heat capacity that are responsible for the moderations of the climate and the body temperatures of living being. It is an excellent solvent for the transportations of ions and molecules required for plant and animal metabolism due to the hydrogen bonding with polar molecules, even covalent compounds like alcohol and carbohydrates that dissolve in water. Now we talk about for the structures of atom, and that what we'll be having to discuss here. So here we go. So structures of atom we have here. structure of atoms. They are as structures of water. So in the gas phase, the water is bent molecule with a bond angle of 104.5 degree and oxygen and hydrogen bond length of 95.7 pm, as will be discussed, and it is highly here. 104.5. This is your 95.7 pm, and this is sp3 hybridization. H, this is plus S minus here, and the H2O molecule. For H2O molecule, it will be this is hydrogen, this is hydrogen as well, and so here it will be, that is the bent structures of water. And the first one is the bent structure of water. The water molecule is a dipole, and this is the orbital overlap picture in a water molecule here. Okay, that has been representing. So with the same that here it is a highly polar molecule and it is an orbital overlap that will be discussed here. In the liquid phase, water molecules are associated together by hydrogen bond, and on the same way, the crystalline form of water is ice, and at atmospheric pressure ice crystallizes into the hexagonal form, but at very low temperature it condenses to the cubic form, and density of ice is less than that of water. So therefore the ice cubes floats on water, and in winter season ice are formed for the surface of the lake provides thermal insulations which ensures the survival of aquatic life, and this fact is of great ecological significance as well. So here we gonna end up with this only, and that what we have to discuss here. So on the same way, here we discuss about the structures of ice as well and the chemical properties of water, but we discuss those in the next coming class. So structures of ice I will just tell you about. In terms of structures of ice here, it is a highly ordered three-dimensional hydrogen bonded structure, and that the examination of the ice crystal with the X-ray that shows each oxygen atom is surrounded by tetrahedrally by four other oxygen atom at a distance of 276 pm, and on the same way the hydrogen bonding that give ice a rather open type structure with wide holes, and these holes can hold some other molecules of appropriate size internationally, and that what we'll be going to discuss here. Now we are going to end up here only, and we will discuss the rest of the topics in the next class, which is the chemical properties of water. So where we'll discuss the amoteric natures and redox reaction involving water and many more, and even though discusses the questions as well. So other than this chemistry, we had done your physics, which is we had done your part 1, part 2, and for part 1, unit 1, unit 2 we had done, unit 3 we are dealing here. And after talking about another one which we had done your reasoning, which is your verbal reasoning and the non-verbal reasoning. In terms of quantitative aptitude, we had started with arithmetical ability where we had completed your 17 topics as well. In the same way, Coming towards this part 2 for class physics, that is chemistry for class 11th. Yes, here we had done your part 1, which is for class 11th, and in that we had done your 7 units. And the name of the units that we had discussed is your some basic concepts of chemistry. Unit 2 is your structures of atom. Unit 3 is your classifications of element and periodicity of properties. Unit 4 is your chemical bonding and molecular structure. Unit 5 is your states of matter. Unit 6 is your thermodynamics, and Unit 7 is your equilibrium. And the same way, Unit 8, which we had discussed, is the redox reaction. Here we had discussed the classical ideas of redox reaction, oxidation and reduction reaction, redox reaction in terms of electron transfer reaction, oxidation number, redox reaction, and electrode processes. Unit 9, which we have to cover up, is your hydrogen. Here we have to cover up the positions of hydrogens in the periodic table, dihydrogen, which is H2, preparations of dihydrogen, properties of dihydrogen, hydrides, which we are dealing, what we had done, hydrogen peroxide we have to do, heavy water, and then dihydrogen as a fuel. Then we'll end up with unit 9 as well. After that we have to cover up the unit 10, that is the S block element, the 11th the P block element, and the unit 12 is your organic chemistry, some basics principles and technique. Unit 13 is your hydrocarbon, and unit 14 is your environmental chemistry. That what we all have to complete it here, so that we discussed one by one, so that it will be helpful for you as well to discuss those in a simultaneous way. But before ending it off, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So here we have to next 1 to 3 class we will be ending it up, this chemistry unit 9. Stay tuned with us. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box.